Okay. Hi. So this is the second part. I want to talk more about this. So this is, again, for any conservative force. And I want you to look at this. So work, you can also think of as, we're playing a little fast and loose with dot products situation here. But work is basically F times delta X, right? And so then that's negative delta U. And then I'm going to do something fancy. I'm dividing. And guess what? Boom. In an instantaneous situation, we get this amazing relationship. This is a super important relationship. It's actually not on your equation sheet. You see things like this on your equation sheet, and recognizing that that's related to the potential energy, you can remember it that way. But this is probably worth putting in your memory bank. So I have a question. Is force a vector or scalar? It is in fact a vector. Is potential energy a vector or scalar? It is in fact a scalar. So what in the world is happening? How do I have a vector on that side? Where is the vector nature of this? Okay. And what is really happening is, let me introduce you to this symbol. This is called del. All right. It's del. Okay. And when you apply it to a scalar, it is defined as, oh, sorry. I'm going to, before I apply it to a scalar, let me just tell you what this is. Okay. When I use it as something called a gradient, okay, so gradient del equals partial x. I will talk about what I just wrote in a second. Okay, if you have never seen this symbol, this is a partial derivative, okay? And all a partial derivative is if you have a function that's a function of both x and y, for instance, taking a partial derivative with respect to x means you keep all the other things, including y, constant, and take a derivative just with respect to x. Partial derivative with respect to y is you keep all the other stuff, like the x is constant, and you do the derivative with respect to y. So these are called partial derivatives, okay? These, of course, are the unit vectors in those directions, in right x, y, and z direction. So what this ends up being in one dimension, right? If I say grad u, partial x of u, oh, sorry, I'm not doing one dimension yet, my bad. Partial u, partial y, j hat, partial u, partial z, k hat. In one dimension, this is negative du, sorry, negative, oh, sorry, I'm tired. Grad u is just du ds in one dimension, okay? So what is really, really true is that force is negative grad u, okay? Guess what? in this class, you don't actually have to know this. Okay, this is just for, that extra level that I like to give you. Okay, this is what you need to know. Okay, however, let me tell you a little bit more about gradient. Because you say, oh, it's a vector, is it? Then what in the world does it mean to have a direction of derivatives? What is the direction of grad? Okay, so the direction of the gradient is, actually I want more room. The direction of the gradient, and this is a word that maybe you actually know, okay, in terms of like steepness, is where you have the steepest ascent, okay? The gradient points in the direction of steepest ascent. So you're thinking of a hill, right? Steepest ascent is like that, right? So what's the direction of the force? If force is negative grad u, the direction of the force is the steepest descent. Well, gosh almighty, that makes a whole lot of sense. That's the direction of the force on it, is the steepest descent. My gosh, I'm just looking at my screen and that is some horrible handwriting. I apologize, but hopefully you followed. So that is the rest of what I wanted to tell you. So let me turn the recording. And thanks for listening.